elements here, borium, hassium, meitnerium, darmstadtium, röntgenium and copernicium, they have a orange color, and these are the elements that were discovered here at the GSI.
Wait, how did it get here? Let us get rid of this gloomy filter in order to make the format of this video more appealing. It's much better now. Today I would like to tell you about, strange as it may seem, the most volatile metal on Earth, that is, about Hassium. And also this video marks the beginning of a new series of videos about so-called super heavy elements, that is about newly discovered radioactive metals, which do not occur naturally and can only exist for a few seconds. The history of Hassium's discovery dates back a long time ago. The first attempts to produce this element with atomic number 108 were made in the USSR in Dubna. Scientists bombarded radium atoms with accelerated atoms of calcium. Such attempts were made right till 1984. Scientists experimented with different elements, while German scientists were conducting similar experiments in Helmholtz Institute near Darmstadt. Scientists synthesized Hassium by bombarding lead atoms with iron atoms, accelerated to 10% of the speed of light. Lead was rolled into a thin layer and installed on a special rotating wheel in order for fast iron ions not to burn a hole in the lead, and also in order to increase the probability of synthesis of new elements. The obtained Hassium-265 had half-life of only 2 microseconds. This time was enough only to detect the new element. After simultaneous synthesis of Hassium in the USSR and in Germany, in the course of further discussions, the discovery was attributed to the German scientist on the basis of a more trustworthy research on the topic. Only 13 years later, the International Union of Pure and Applied Chemistry gave the new element its name, Hassium. The element was named after the land of Hesse, where the GSI Helmholtz Center for Heavy Ion Research is located. Since then, about 100 atoms of Hassium with different masses and half-lives have been obtained in this institute. Throughout the whole research there has never been produced a single stable isotope of Hassium. There haven't even been produced isotopes which could exist for a minute. However, in 1963, a Soviet scientist came up with a theory that there exists a naturally occurring element with atomic number 108 with a very long half-life in some minerals. For instance, in molybdenite. The inner structure of this mineral is severely damaged due to the emission of highly accelerated alpha rays. And Hassium is a highly radioactive metal, which decays releasing high energy. However, there haven't been found proof to back up this theory. Scientists didn't have enough Hassium to study its physical properties. That is why, only thanks to powerful computers and mathematical models, scientists managed to work out this metal's possible properties. Theoretically speaking, Hassium is a metal, the density of which is 2 times that of gold. It has got a very high melting point, similar to that of the elements from the same group in the periodic table, such as osmium and ruthenium. However, these properties are only presumed, because no one still knows if they are correct. To say with certainty, there should be produced at least a few thousand millions of Hassium atoms to see its real properties. It's a bit easier to determine this metal's chemical properties. According to calculations and assumptions, from a chemical point of view, Hassium has to be similar to osmium, and it also has to form volatile oxides when reacting with oxygen. In order to study chemical properties of Hassium, German scientists had to create a special isotope, Hassium-217. It was obtained through bombarding of radioactive isotope curium chain with accelerated magnesium atoms. The isotope obtained existed only 10 seconds, but it was enough to study its chemical properties. The freshly obtained 7 atoms of Hassium were passed through gas chromatograph, which contained helium mixed with oxygen. As a result, Hassium was oxidized to tetraoxide, which was quickly detected just as was expected. All of that happened very quickly, in less than 10 seconds, in order not to lose the precious Hassium atoms. As a result, scientists managed to confirm that the predicted chemical properties were correct. That is why it can be called the most volatile element. Even freshly obtained Hassium atoms from the accelerator can immediately volatilize in the form of oxide in the air. Thus, even negligible amounts of this element can easily be lost if they react with oxygen. In the future, scientists from the Institute of Heavy Ions are also planning to conduct reactions of Hassium with cyclopentadienes in order to obtain so-called Hassium metallocenes and check whether it's similar to osmium and ruthenium. Unfortunately, they have only been produced about 100 atoms of different Hassium isotopes, and it is unlikely that we will even see it in the form of a piece of metal. However, if it does happen one day, we will deal with the most dense and unusual metal on Earth, which will volatilize in the air quite quickly, and will also be quite radioactive. At this point, it's hard to find practical applications of superactinides. All the experiments with them are conducted for the sake of studying them. Although, who knows, maybe in the future, as was the case with many discoveries, these new elements will have practical applications many years after their initial discoveries. That's all that I wanted to tell you about such an unusual and volatile metal as Hassium. If you like videos about superactinides, don't forget to mention that in your comments and subscribe to my channel. In the future videos, you will see how super heavy metals are synthesized and what equipment is used to do that, and also why it is worth doing all of that and how much it all costs.